So once we have collected data, then we need to start analyzing the data. One way to display and summarize data is to use statistical graphing techniques. The type of graphs we use depends on the type of data collected. Qualitative data use graphs like bar and pie chart, and sometimes you call pie chart as a circle graph. Quantitative data use graphs such as histogram. Okay, what else can we use for quantitative? Histogram and line graph, point graph, point graph. What else? Stem and leaf, the one that you like. Right? What else? Pie chart. No, pie chart we use it for what? Qualitative. Okay. So this is a big picture of the whole thing. Here you can see it. That summarizes the whole list. Okay. Okay. So the shapes. Describing the shape of a histogram. So a couple notes here on some vocabulary you can use to describe the shape of a histogram. And now with real world data, it's never perfect. Histograms are never perfect in any of these shapes, but they tend to be close to one of these shapes. Not always, but generally. So if you take a look at, this histogram, if I draw a line like this, it looks like bell shape. Okay. Another graph is this one. Okay, the picture of symmetry is not here. It's basically the same on both sides. So the left side equal the right side. Okay. Another one, skewness. Now, where is the tail? On the right side. We call it what? Skew to the right, because the tail is on the right. Now, there is something called skew to the left. That's where is the tail? To the left. Okay. So conclusion, frequency distribution. The frequency distribution provides a clear summary of how often each value of category occurs within a data set. It's always us to see the distribution of values and understand the pattern of spread of data by organizing data into groups and displaying the frequencies. We gain insight into the central tendency, variability, shape of the data distribution. This facilitates better understanding and interpretation of data sets, aiding in decision making, analyzing, and communication of findings. Now with box and whisker plot. It is important not just to be able to draw the box and whisker plot, but we also need to be able to describe the shape of the box and whisker plot that we end up with. So let's take a look at a new type, which is called what? Box and whisker plot. Okay, how to make a box and whisker plot? It's a diagram that shows the statistical distribution of set of data. This makes it easy to see how data is distributed along a line, a number line. And it's easy to make one yourself. Let's say that we start with number 4, 3, 4, 2, 3, 1, and 5. So the first step is what? Place the number in ascending order. So we're going to be starting with 1, 2, 3, 4, 5. Now we're going to look at step 2, the median, which is the middle number. Here, the middle number, you can visually see this like 2 numbers on the right, 2 numbers on the left. So the middle number is 3. So the median here, or the middle number, is 3. And we give it another name. We call it what? Second quartile. So what is the first quartile? Quartile first and the third quartile. Okay, we can get the second. The median of 1 and 2 is what? What's the median of 1 and 2? 1 plus 2? 3. Divide by 2 because they are two numbers. So your median of the first two numbers is what? 1.5. That's called quartile, first quartile. And what's the second quartile? 3. 3. Now, what do you think about the third quartile? We add the last two numbers and divide by 2, you get 4.5. So what's your first quartile? 1.5, because I add the first two and divide by 2. What's the second quartile? The middle number. What's the third quartile? The last two numbers, you add them and divide by 2. So the first one is 1.5, second quartile 3, and the fourth quartile and the third quartile is 4.5. Is this clear? You're gonna ask me what I'm gonna use this for. We'll find out now. You're gonna draw the number line. So draw this on your paper, or if you have paper, and then you're gonna make 3 lines. Where's the first line? 1.5. What is the last line? 4.5. What's the middle one? 3. That's it. Easy? Good? If you understand, raise your hand. If you are like half understand, raise your hand. Half understand. Okay? Huh? Okay, good. So far we got first quartile, second quartile, and the third quartile. Now we're gonna make the box, right? Around that. You get the rectangle, right? So step 5 on the blade line, graph first, second, and third. Step number 6, make a box by drawing horizontal lines connecting the quartiles. Okay. Step number 7, mark your outliers. Find the smallest and then the largest. What's the smallest number you have? What's the largest number you have? 5. Okay, step number 8, connect. Okay, so mark these points with a small dot. Okay, step number 8, connect your outliers to the box with horizontal line. Okay, where is the graph? Do we have a graph? Yeah, see this? So the smallest number is 1 and the largest number is 5. That's it. You're done. Huh? You learn how to do the whisker plot. Okay. Step number 9, finished. Look at the box and whisker plot to visualize the distribution of numbers in any data set. You can easily see, for example, whether the number in the data set bunch more in the upper quartile by looking at the size of the upper box, as well as the size of the upper whisker. Box and whisker plot are greater alternative to bar graph and histogram. There is some resources here. Maybe you want to watch that. Okay, so another guided practice is asking you for the range. How can I get the range for the interquartile? Yeah, quartile 1. Remember, now we are looking for the range of what? Not the numbers. The range of what? The quartile. So you're looking at quartile 1, quartile 3. Take away quartile 3 from quartile 1, because quartile 3 is always bigger number. You cannot say quartile 1 minus quartile 3. or you're going to get minus. So here, quartile 3 is 89, quartile 1 is 67, subtract, you get 22. So that's the range. Now, another question here, lower pound. You're going to get quartile 1, take away from it 1.5. Okay, this is a rule that you have to follow. Times the what? The interquartile range. Okay, so if I zoom in here, take a look here. Quartile 1, how much? 67. Okay, 1.5 times what? Interquartile. Okay, I'll just put multiplication here. So just you need to multiply times 1.5, and then you get away from 67. 67 is what? Quartile 1.
Do you mean by the interquartile that is 22? So multiply it by 22?
Yeah. So use this result to put it here. Okay. Can I make it bigger? Yes, I can make it bigger. Is this clear now? Okay. So I'm using the 22. Okay, what about the upper bound? Quartile 3, because the upper is the one on the right side, right? Quartile 3. But instead of subtraction, we're going to do addition. And then you multiply 1.5 times interquartile. What's the interquartile we said? 22. Is this clear? So let's this bigger a little bit so you can see. So this is a formula that you have to apply. So where did I get these numbers? I got them from here. Okay. You can see here the numbers. And what is 67 here? Consider. Okay. So you see here, I count how many numbers. How many numbers up to here? Okay. And how many numbers up to here? Also 7. So what's the middle here? 89. And what's the middle here? 67. So that's where I get the 89 and the 67. Now, what's the purpose of this? That's the purpose here. To identify the outliers. What's mean outliers?
The ones that are too far off.
Right. Like for example, do we have outlier in our class? Look in the class and tell me where is the outliers. No, there is outliers. Yes. Why are you sitting in the back? Why don't you sit in the front?
No, so you're the outlier.
Yeah. Yeah, I'm another outlier. So we have 3 outliers. So please sit in the front so you can see. Okay. So the outliers here is what? What's outliers here? Well, how did I know? Because the lower boundary is what? So the last value is 34. And the highest value is what? 122. So if you have, like, let's say, for example, you have a number 123. Please consider what? Outlier. But here we don't have 122. We don't have, the last number is 99. Yes. Right. So that's why we use this, all of these formulas to get the outliers. If you understand the purpose of this, raise your hand. If you half understand, put your hand like this. Half? Okay, tell me.
I don't understand the last part of outliers.
Okay. The number I started with, those are the numbers, right? Correct?
Yeah.
And those numbers are what? Even. So I have to split them into 7 and 7. The question here, what is the outliers? How can I know, is it going to be 32 or is it going to be 99? How do I know? You tell me. Just by looking.
From what I understood from what you said, it's because here from the information that we have from the
Let's say for example we don't have this information.
Oh.
Which one is the outlier here? يعني برا الحدود يعني برا out of the reach, out of the range of the data that you will not use it. Okay, so how can I know the outliers? We have to follow these steps. First, we find the interquartile range, and then find the lower boundary and the upper boundary. And then anything before the lower boundary, it's what? Outliers. For example, I ask for all of you to type on the survey your answers from 1 to 4, right? 1 to 5. Let's say, for example, one of you wrote down 9. Okay, is it outlier? Yet it's outlier. For example, I ask all of you to write down your ages, and you write 23, 24, 25, 19, 16. Somebody wrote 9. Somebody wrote 99 by mistake. He wrote down, instead of writing 19, he wrote 99. So when I get the data, I collect the data from you, I look at the data. Then by my eyes, I can say, oh, somebody wrote 9. That's impossible. That's outliers. And the 99, it's also outliers. So I can eliminate these two from my data set. But what if you are collecting 3,000, 2,000 data sets? You will not be able to do it manually. So you have to do it by the computer or Excel. The Excel will tell you which one is the outlier if you do the calculation on the Excel. Is this clear? Because the data is not going to be like 14 pieces of data. It's going to be more than that. Okay?
But doctor, I have a question. الحين for the lower bound we minus 1.5, the upper bound we add 1.5.
This is a formula. It's not my invention. It's a formula that we have to follow. Yes.
Okay.
And the abbreviation for this IQR. So you don't get confused. I got it from here. Yes.
When we got the 34 and we got the 122, how did we come up with the outlier?
When we get 122?
Yeah.
Okay, that's the upper bound. If you have a number here, 123.
That's an outlier.
That's outlier.
So anything that's not between 34 and 122 is an outlier.
Right.
Okay, well, how does 22, what do I do with this default?
The 22, that helps you to get the lower boundary, and it helps you to get the upper boundary.
Okay, beautiful.
Okay, so here the outlier here is what? 32. It's clear?
We can have 2 outliers.
Yeah.
But wait, doctor. And this is in the case where the range of number is even. Let's say it's odd and you only have one median.
Right. Then in the one in the middle, you put it in the middle, and then you take the one on the right and the one on the left. And then find what is the middle. Let's say, for example, here we have 78. So 78 will be in the middle here, right? So don't worry about 78. You take the last 7 and the first 7. And the one in the middle, just leave it as it is.
And you said the lower bound, upper bound, middle.
The one down, 78, don't worry about it.
We will not use it.
Yes.
It's just showing me where I'm going to go.
Right. Okay. So can you do 1? Did you write the formula or? Now, what are the numbers here? Do you have the numbers? Okay, those are the numbers. 32 until 99. How many numbers those? 14?
Yeah.
Yalla, do it. So put the numbers in what? The first step. Put the numbers in what? Ascending order first. Okay, I'm just making it easy for you, or it's easy. Okay, next.
Find the median.
So do we need to find the minimum and the maximum? What's the minimum and maximum?
99 and 32.
Minimum 32 and the maximum
99.
99. And the numbers already in ascending order, correct? Yeah, ماشي. It's good. Step 3, find the median. Find the lower quartile and the upper quartile. So how can we do this?
We follow the formula Q1
And then find the median.
How can we find the median? Median is the middle number.
Yes.
Now, how many numbers we have? So we cannot exactly, so we're going to be 7. No, we're going to add 7 plus 1. So 7 plus 1, how much? It's a rule. 7 plus 1. How much 7 plus 1? And then divided by 2. Are you sure it's 4? Yeah. Sorry. It's I'm sorry. It's 14, correct? Just jump to another thing. So it's going to be 14 numbers plus 1, not 7. 14 numbers plus 1 divided by what? By 2. So they give you what? 7.5. So now you're going to count 1, 2, 3, 4, 5, 6, 7, and the number in middle here is supposed to be what? The median. What do you expect the number will be in the middle here? 78. Yes. So we take that number. It's not there, but we write it down. Okay? 78. Then after that, yes.
كان كذا نجمع الرقمين اللي في النص طيب بعدين نقسمهم على 2 فنوجد المثل كذا.
Okay, see another method يعني. Okay, 77 plus 79 divided by what? By 2. And they give you what? 78. Same answer. Correct? Did I come?
Wait, no, it's right. Yeah, that was the same one. You need to put it in the brackets.
You can use the first way or the second way. I think it's better to use the first way because this is.
But only if there's no median, right?
But there is no median here, but we assume it's the median is 78. Even if it doesn't exist. Regardless, if it's not there, just put a number. Okay? Now we need to find the what? The first quartile. How can I find the first quartile or the lower Find the lower quartile. How can I find the lower quartile? Right. So which one? 67, right. So write down the lower quartile, or the first quartile is going to be what? 7 plus 1 divided by what? By 2. Equal what? The fourth place. Which one is the fourth place? 1, 2, 3, 4. So the answer here is what? 60. The value is how much here? 67. Is this clear? Now let's go for the upper quartile. The upper quartile will be the same thing. 7 plus 1 give you the fourth position. What's the fourth position?
89.
The value is 89.
Doctor, I don't understand why you're doing this.
Say again.
I don't understand why you're doing this.
Finding the lower quartile
The median تبع lower quartile.
and the upper quartile. Okay, that's it. So that's what is required. That will help us to do what? To do what? You remember to find the lower boundary and the upper boundary? But you need to find the interquartile range, which is not required in this exercise, but it kind, you know, like it's a continuation. Consider this like continuation. Okay. Okay. So far so good. Now let's take a look at some of the classification of skewness for whisker blot. So take a look at this. This is normal. It looks normal, right? Minimum, maximum, medium, first quartile, third quartile, and this is we call what? Second quartile, which is the medium or the middle number. Now skewness to the, where is the tail? Where is the tail? The tail is here, see? So that's called what? Skewness to what? To the right. Where is the tail? So skewness to what? Left. So if you get one of these shapes, you know that there's something wrong with the data. Can you fix that? Yeah, possibly. By asking them to come and move to the front. And I join. Okay. Now it's your turn now. Can you please look at this example here and tell me how much is the mean and which one has an outlier? Which hospital? It said here, number of patients in 7 days. Can you see that? Number of patients. How many patients here? Write down 35 here. How many patients, the median? We're talking about this line is a median, huh? How many patients or the median here? How much? 35? Write down 35. But the question comes here, which hospital has an outlier? Why?
Because there's one that's really far away.
Right. See? The average for 7 days are how much? 30? 35. So how many numbers total here? This is what? This is going back to our example with commute time. Maybe this is the first time you see this, but this is a commute time. They take 4 minutes to go to work. Another person takes what? 6. Another person takes 7. Another person takes 7, and so on. The last person take how many minutes to go to work? 49. Okay, so we need to graph this. Okay, so the first thing, we have to count the numbers we have and put them in ascending order. Can you put them in ascending order? Yalla, do it now. They're already in order. Okay, thank you. If it's not in order, what should we do? Okay, from small to the largest. Then the next step is to do what? To find the minimum and the maximum for the data. What's the minimum? 4. Write down 4. Minimum R is 4. And what's the maximum?
49.
Write down 49. Next step, step number 3, find the median. How many numbers do we have total? 20. So our median will be between what? We have 10 numbers here, 10 numbers there, right? So we can use, where she went? She left. So we can use the same thing she did. Add 21 plus 24, divide by 2. 21 plus 24, how much?
45.
And then divide it by 2. And that give you what? So let's say it's 22.5, the median number. Okay, up to here is clear? If you understand, raise your hand. If you half and half understand, put your hand like this. So everybody's okay? Next. Step number 4. Place parentheses around the numbers above and below. Now we're going to find the quarterless. Quarter 1, quarter 3, and so on. So how can we find quarter 1? So how many numbers do we have? How many numbers do we have? Total 20, right? So we look at 10, right? 10 numbers. We take the first 10 numbers and write them down. And then we're going to have how many numbers? 5 numbers on the right and 5 numbers on the left. Is this clear? Now we need the middle number here. So we're going to add what? 11 plus 13 divided by 2. You get what? 12. So quartile 1 is what? Is this clear?
Yes.
Now we're going to go for quartile 3. How many numbers? 10. We're going to, of course, 10 is going to be 5 on the right, 5 on the left. We add those 2 numbers in the middle, divide by 2, and you get the quartile 3 is 36. Okay? Now you're going to make a number line. And when you make number line, you write down the numbers 4 until 40. And then you remember I told you have to make a line. So the first line is going to be quartile 1, third quartile, and the one in the middle, the invisible one, the one that we said the number doesn't exist, 22.5. Is this clear? So you need to write the summary of that now. So we wrote down the minimum 4, the maximum is 49, quartile 1 is 12, the median 22.5, quartile 3, 36. Up to here is clear? Okay, step 7, draw the number line that will include the small and the largest one, largest data. Like we did, of course, it's going to be like this, right? Now we're going to point out in the top of each one which one is a minimum, which one is a maximum, and the median, quartile 1 and quartile 3. Then you're going to make what? The rectangle. The first one is what? Quartile 1, quartile 3, 2, quartile 3. And what's left? The minimum and the maximum. You're going to tell me what is 4? We cannot write 4 here, but we're going to write down like 5, 10, 15, 20, because it's going to be too much work to write down like numbers like 4, 3, 5, 6, 7, 8. So take by 5. It's going to be easier for you. Is this clear? So we did the box and then just do the minimum and the maximum. Here he wrote down by how much? By 6, 3 and 6. 3 and 6 give you 9. 9 plus 6, how much? 15. 15 plus 6, 21, and so on. Okay.